Welcome. Now we're going to talk a little bit about equation solving principles, which for our purposes should be review. We have both an addition and a multiplication principle that we can use for solving. Now, the first addition principle says that if we have an equation, sum A equal to sum B, essentially, using this arrow to mean then, what this says is I can add the same value to both sides of the equation. Now, notice this is only the addition principle. And I say here that we can add or subtract. Well, in our mind, adding and subtracting should be beginning to sort of mean the same thing, just in the opposite direction. To add -2 is to subtract. So addition can be thought of as subtraction. So essentially all this says, and what we know, is that we can add the same value to both sides of an equation. Same thing goes for the multiplication principle of equality. If we're given an equation, then we are allowed to multiply on both sides of the equation by the same value. And then again, keeping in mind that multiplying is very similar to dividing. Remember, division is multiplication by the reciprocal. So if you can multiply on both sides, you can also divide on both sides of that same equation. And we do have a new word, a new vocabulary term here we want to talk about, and that's the zeros of a function. And basically a zero is some C value. C just represents a number. And so for any C value of the function, f, it's called a zero if my output, or y, is equal to 0. Right? So if I plug in C and I get out 0, that means C represents what we call a 0, not 0, a 0. Okay? And so another way of saying that is plugging C into the function. If the output is 0, if f of C is equal to 0, then C is a 0. And furthermore, if we know that C represents some 0 value, then we can say that C0, that ordered pair, represents the x-intercept. So the 0 is really the value of x at the x-intercept. And all we need to do to find the zero of a function, is to let f of x equal 0. Remember up here I said y is equal to 0. Well, do you recall that f of x is the same thing as y? So if a problem asks you to find the zeros, that means you let the function equal 0 or you let y equal 0. That's all that means that you need to do. All right, to find a 0, you're going to solve for the x value where that exists. So let's look at an example of finding a 0, and then we'll look at solving two linear equations. In this example, we're asked to find the 0, and we're given a function, f of x equals 8x plus 2. So as I just said, if you're asked to find the 0, that means you let f of x be 0. So instead of f of x, I'm going to write 0 here. That means we need to solve 0 equals 8x plus 2. So I'll subtract x using my additive property of equality. I'm actually going to add -2 to both sides. And I'm really just saying that, I'm adding the value to emphasize it's the additive property of equality. And when I do that, 0 plus -2 gives me -2 on the left, and I have 8x left on the right. And then I'm going to multiply by the same value on both sides of the equation. I'm going to multiply by the reciprocal of 8, which is positive 1/8. Those guys cancel, and I'm left with -2/8 equals x, or rather x equals -1/4. This is my 0. right? So if you're asked to find the zero of a function, all that means you need to do is let f of x, or the y, be equal to 0. So that means at x equals -1/4, this function has an x-intercept of -1/4, 0. So notice I wrote the x-intercept as an ordered pair and the 0 as just a value. That's just a little bit of notation there. All right, and again, I wrote up here, I was using my additive property of equality. I added the same value and I multiplied by the same value on both sides of the equation. I just want to emphasize that I could have also solved this. 0 equals 8x plus 2. I could just say minus 2, that's -2 equals 8x, and divide by 8. -1/4 equals x. So writing it a little less wordy. All right, let's look at solving two equations. This first example, I like to show you because it deals with fractions. All right, and so fractions are a big F word for people in math. They don't like. We have a hard time dealing with them. So a strategy that we could use would be to clear all fractions by multiplying all terms. In this case, we have 1, 2, 3 terms. Terms are separated by plus and minus signs by the LCD, the least common denominator. So I have a denominator of 1, a denominator of 4, and a denominator of 7. In this situation, my least common denominator is 4 times 7, or 28. So what I'm going to do is I'm going to take each of these terms. I've got 5 times 28 minus 3 over 4 times 28x equals 2 over 7 times 28. 5 times 28 gives us 140. 4 goes into 28 7 times, so I'm left with 7 times 3, or minus 21x. And that's equal to 7 goes into 28 4 times. 4 times 2 is 8. So this strategy, multiplying each of my terms by the LCD, gets rid of those fractions, and now it's very easy for us to solve using our additive and multiplicative properties of equality. So the first thing I'll do is I'll add -140, or subtract -140 to both the left and the right side. So on the left, that cancels, and I'm left with -21x, and on the right, I'm left with -132. So now I will use my multiplicative property of equality. I'm going to multiply by the reciprocal. Of course, you could just divide on both sides by -21. Writing that either way means the same thing, and that gives me that I have x equals 132 over 21. And that fraction, of course, reduces to 44 over 7. So that would be my answer here. You should always check. And the easiest way to check would be to take that original equation, 5 minus 3/4 x equals 2/7, and we'll just plug this fraction right in there. So that gives me 5 minus 3/4 times 44 over 7 equals 2 over 7. 4 goes into 44 11 times, so I have 5 minus 3 times 11, 33 over 7 equals 2/7. 5 in terms of sevenths, that's going to be 35 sevenths minus 33 sevenths equals 2/7, which means this checks. We know we have the correct answer here, 44 over 7. All right, let's look at one more example which has multiple steps. In this example, we're going to solve an equation, -2 times the quantity 4 minus x plus 3 equals 6 minus the quantity x minus 1. Now, since this problem has so many steps, or different ways that we could go about, or methods that we're going to be using, strategies that we'll be using inside the solving process, I like to kind of write down an order or recipe for a way that you should be working through these. So one thing that we always want to do is make sure that we simplify on either the left or the right side first if we can. That means we're going to carry out any distribution and then collect any like terms. This also may be a situation where we would multiply by the LCD to clear any fractions. In this case, we don't have them. Then we're going to start using the addition principle. Once we have simplified each side individually, we'll use the addition principle oftentimes twice to collect the variable terms as well as the constant terms on opposite sides. So we'll get all the variables maybe on the left and all the constants on the right. And then our variable, our x, will likely have a coefficient. So we're going to use that multiplication principle and we will divide to cancel that coefficient on x. Of course, we should always remember to check. All right, so the first step here is we're going to simplify on the left side and then on the right side individually. On the left side, I have some distribution that I can do. So this is going to be negative 8 plus 2x, and then we have a plus 3. Of course, I have some constants that I can add together. I'm combining like terms, and negative 8 plus 3 gives me negative 5 plus 2x. Then on the right side of the equation, I have 6 minus the quantity x minus 1. Now that's 6 take away all of this, which means only this minus sign is going to distribute to both of those terms. And that gives me 6 minus x plus 1. So right here, this is something that I would really often see a student leave out when they were working through this problem. So making sure to distribute that negative to any and all terms inside the parentheses. The 6 is not getting distributed. So I have 6 minus x plus 1. And I can add the 6 and the 1. That gives me 7 minus x. So now I'm just going to take my constants, I'm going to collect them on the right, and my variable terms, I'm going to collect them on the left. So I'm going to add this x over. So plus x plus x. I have negative 5, that's plus 3x equals 7. I'll use my addition property a second time. I'll add 5 to both sides of my equation. That gives me 3x equals 12. And then I will divide by 3 on both sides of the equation. That leaves me with x equals 4. And that's my final answer. Remember, you should always check your work. So negative 2, 4 minus 4 plus 3 equals 6 minus 4 minus 1. So 4 minus 4 is 0, so negative 2 times 0 plus 3. Anything times 0 is 0. I have 3 on the left. And on the right, I have 6 minus the quantity inside my parentheses. Remember your order of operations. 4 minus 1 gives us 3, and 6 minus 3 gives us 3. This is a true statement. This checks. We are good. One thing I did mention there, I talked about the order of operations. Please excuse my dear Aunt Sally. That's likely something you've heard before. So we would do anything inside the parentheses first. Then we would apply any exponents, which we do not have here. Then you multiply and divide from left to right. Then you add or subtract from left to right. So notice I kind of wrote that a little bit differently. Please excuse my dear Aunt Sally. Parentheses, exponent, multiply, divide, add, subtract. So we've done two examples solving two different linear equations, one with fractions and then one with multiple operations. I want to take a second to talk about two special cases. So some special situations you may deal with. Suppose I have, say, 2x minus 17 equals 2 times 3 plus x. In this situation, if I were solving this equation, we would say, well, that's 2x minus 17 equals 6 plus 2x distributing. Then I would subtract 2x from both sides to get my variable terms together. And what we notice is we end up with negative 16 equals 6. Now, is that possible? And of course, that's not possible. This is what we would call a contradiction. So if you end up with a situation like negative 17 equals 6, 10 equals 2, 4 equals pi, regardless of what you have, if it doesn't make sense, your answer will be no solution. So this is a situation where we have a no solution answer. The other special case that you might end up with would be maybe if we had 3 times x minus 5 equals negative 15 plus 3x. So when you look at solving these equations and completing some distributions, we'd have 3x minus 15 equals negative 15 plus 3x. So again, I would subtract negative 3x from both sides. And here I get negative 15 equals negative 15, which in this situation, this is an identity. This is where something is equal to itself. And in that situation, the solution would be all real, let's write that right, all real numbers. And the way we write all real numbers in this algebra class is we say negative to positive infinity. So if you end up, when you're solving an equation with an identity, that means all real numbers. And if you end up with a contradiction, you will have no solution. So that's it. That's basically all you need to know about solving different equations. You really just need to practice solving different types of equations so that you know how to find the answer correctly. As always, send me email. Let me know if you have any questions or concerns. Good luck.